Okay, so now let's try to do variabilities. So there are a lot of different measures of variabilities, and here we're going to talk about range, MAD, MSE or variance, and the standard deviation. So let's try it. So for range, in Excel, there is no function called range. What we may do is to use min or max. So let's say I want to see what's the minimum value among the first 10 days of CNT. I'm going to get 801. So that's exactly the minimum value, right? For maximum value, that's the same thing. I can choose a range and get the maximum value. And then if I do a division here, I get range. So that's range. For MAD, I need to calculate it by myself because in Excel there is no function called MAD or whatever. So let's very quickly do this. So for CNT, I have all these original values. I first calculate their average values, okay? The average of all these values. That sounds good. And then I should calculate the deviation. So I'm going to use CNT to minus the average value. Okay, so this number minus that number, and of course here for B12, because I know later I'm going to copy and paste those formulas, here I'm going to fix the two dimensions. Okay, so I get all these values as the deviation. And then what I should do is that I should get their absolute values, okay? I should take the absolute value for all these deviations. So what I may do in Excel is that I can use the function called ABS, absolute values. So I have absolute value for each one of them. Okay, now they all become positive. Good. So now, as we know, the next thing is that I need to sum them up. So this is the sum of deviation, sum of absolute values of deviation. So then all I need to do is to divide this particular number by the total number of values I have, in this case 10. So the MAD in this particular example is 287.8. So that's my MAD. Okay, that sounds good. And then how about variance or MSE? So let's try to first calculate MSE by ourselves. If that's the case, what we need is that we need to take square instead of taking absolute values. So I'm going to take the deviation and then square it. Okay, I get all these values. I want to sum them up, and then divide the thing by the number of, let me just sum them up first. Okay, so this is my sum of squared deviations. Then all I need to do is to take this number divided by the number of values I have. Okay, so this is my variance. And if this is the MSE or the variance, we should not just need to do all the calculations by ourselves every day, because variance is so frequently used. So it's good that in Excel we have functions called VAR, stands for variance. So here we have var.p and var.s. So these two are indeed different. If we are calculating variance with respect to a population data, then we should use var.p. If we're doing that with sample data, if we are calculating sample variance, then we need to use var.s. So at this moment, we are not yet going to inferential statistics. So at this moment, we will just use var.p. Okay, that makes more sense because what we are doing is that we have a set of data. That's all we have, and we try to calculate the mean squared error of all these 10 values. So it's more like describing a population. If we are trying to describing a sample and use that to infer the population, then that's another story, and we will do that in the future. Okay, so all I need to do is to select all my original 10 values and put them into this var.p function. I'm going to get exactly what I should get if I do it step by step. Okay, so that varp is something like this. We may try vars, and very quickly we can see that the value is a little bit different. And if you pay attention to the lecture videos, you know why is that. Because their denominators are different. For the population variance, the denominator is n. For sample variance, the denominator is n-1. So that's why for the samples variance, you're going to see a slightly larger value. So let me emphasize it again. Indeed, we need to distinguish the difference between population variance and the sample variance. But we will delay our discussions and will delay the use of sample variance later until we really focus on inferential statistics. Okay? At this moment, just calculate population variance. And another good thing is that if you have thousands of values, millions of values, these two functions doesn't really matter, so you don't need to worry too much about it. Okay, lastly, standard deviation. So given that you have MSE, then you just take square root of it. Then it's standard deviation. So here I'm using the function sqrt square root. To apply to any value, you get the square root. And in this case, this is standard deviation. Okay, and standard deviation is a very important thing. So it's not surprising that we have this function, stdev.p, standard deviation for population. And here you select that 10 values you are talking about. Well, 311. Exactly the numbers that you get if you do it step by step. So you also have stdev.s. And of course, if you select these 10 values, you expect the outcome to be the square root of this particular number, the sample variance. So it's slightly larger, makes sense. Okay, so at this moment, please use the population version. But if in the future you know you are doing some kind of inference, then what you should do is to use the sample version. Thank you.